Hello, this is part 3 of combinations of transformations of sinusoids. We're going to just go through a few quick examples, and then you're going to have some time to work on an in-class open book assignment, which I will collect from you when I return, hopefully next week. So we're going to take a look at first drawing the sine curve. So remember that the sine curve, it starts at the 0 degrees. And it has a period length of 360. So we know that it's going to make it back to that starting point at 360. We know that it's going to cross back on this central axis at 180 degrees. We know that halfway between 0 and 180, it reaches its highest amplitude of 1. And at 270, it reaches its lowest amplitude of 1. And it repeats in the opposite direction on the other side of the grid. So hopefully you're familiar with sketching this curve. You've probably done this probably what seems like a gazillion times already. So we'll go ahead and sketch in the sine curve. It doesn't have to be perfect, but there we have it. So once we've sketched that, at the very bottom it says to state the domain, the range, the amplitude, the period, the phase shift, and the vertical translations, or vertical translation. So let's go ahead and do that based on the sine graph. So for the sine graph, for part A, just the regular one, we know that the domain is always going to be the same regardless of what sine or cosine graph you're drawing. We use theta to represent the degrees instead of x. So the domain is a set of theta such that theta is an element of the real numbers. It could include every single, I know I drew a dotted line, but it's going to include every single point on that grid. Then we have the range. The range is, remember, the values of the y. So it's the set of y such that y is going to be between -1. So -1 is less than or equal to y, which is less than or equal to +1. And y is also an element of the real numbers. So that's the domain and range. When we're looking at the amplitude, it's the height of one of those sections of our curve. So we have an amplitude of 1. So from that central axis, we either go up 1 or down 1. So our amplitude is 1. We have a period which is 360 degrees. So that's one complete sine curve. And then we have no phase shift, and we don't have any vertical translations. So you can put the phase shift is 0, and the vertical translation is also 0. So that's what we have for the basic sine curve. Now we're going to take a look and draw the curve for the transformation y equals 3 sine of theta plus 120 degrees plus 1. So in here for part B, we have a few things that we need to remember. Remember, if there is a number in front of the theta and there's only one single set of brackets, you factor that out. That's not the case for B, but I just want you to get in the habit of always looking for that, because that is a really common mistake that people forget to do. Also, make sure you look for any negative numbers in front of the A or the K to see whether or not there's going to be a reflection. And also, hopefully you'll remember now that the reflection either in the y-axis or the x-axis will produce the same curve, so keep that in mind as well. So by looking at this equation, I can see we have an amplitude of 3. We have a phase shift of -120. It's the opposite of what's inside of the bracket. And we have a vertical translation of +1. And that's important for us when we are thinking about stating our domain and range. So our amplitude, again, is 3. Our phase shift is -120 degrees. And we have a vertical translation of 1. Now, there's no K value, so our period still stays at 360 degrees. So we just have to state what our domain and range is going to be. The domain will always be theta, such that theta is an element of the real numbers. And the range is going to be the value of y, such that y is now going to be between two different numbers. And you can leave yourself some space to figure out what those numbers are. And then we know that y is going to be an element of the real numbers. So how do we figure out the numbers that y is in between? Well, we look at our vertical translation. So vertical translation is at 1. So we know that that's going to move that central axis up. So we're now going to have a, instead of it going through the equation of y equals 0, it's now going to go through the equation of y equals 1. And because that's going to be sort of our central axis point, we can think about, okay, if we have an amplitude now based on that value, well, I know that I'm going to go up 3 from here. So I'm going to go up from 1 all the way up to 4. So that's going to be the highest point that the y is going to equal. And I'm also going to go down 3 from here. So I'm going to go down to a lowest point of -2. That seems to be a good trick to figure out our range for these curves. So now we know that we're going to, normally we would start right here at 0 to begin our sine curve, but we have a phase shift of 120. So I know that I have to, and it's -120. So I'm going to the left 4 units because every unit is worth 30 degrees. So that's going to be my starting point. So I'll go ahead and put a circle around that. For my original sine curve, my starting point was right at 0, 0. So now that I've got that there, I know that my period is still 360. So from here I can go over 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's where my first sine curve is going to end. I know that halfway between there is going to be where it's going to change directions. So I can count over 6. 1, 2, 3, 4, 5, 6. There's my halfway point. And halfway between these 2 points, I have no reflection. So I know that I need to start thinking about what is my highest point going to be. So between here, I'm looking at the halfway points, so 3 over. And then my amplitude is 3, so I'm going all the way up to 4. And then in between the next 2, I have my halfway point, and this is going to be my lowest point, so I'm going to go all the way down to -2. And I'm going to do the same thing as far as I can on this side. So I'm going to go over 3, 1, 2, 3. This is going to be my lowest point again. From here, I'm going 1, 2, 3, and back up at that central sort of axis there. And that's as far as I can graph comfortably on this. If I wanted to, I could go further on the right-hand side. So I could go over 1, 2, 3, and I'm going to have another highest point at 4. And so from there, you have your starting point, you've taken care of your vertical translation, your amplitude, and our periods, and now we can go ahead and connect those in a nice curved line. And it's not going to be perfect, but you're going to do the best that you can. If you have different colors, you may wish to draw these in different colors instead of always drawing that. I'm hoping that these points here in the red will help you sort of distinguish where part B is. There are solutions posted on Brightspace, so you can take a look at a more color-coded version of this graph. Next, we'll take a look at part B, or part C, sorry. We have an amplitude of 1/2. So you can either keep it as a fraction or you can write it as a decimal number, whatever is easier for you to wrap your head around. we know that it's going to have a, there's no phase shift. I'm not adding or subtracting anything in the same bracket as my theta. I know that I do have a K value, and I know that my K value is negative. So I'm going to have a reflection here, and that's important to note. So instead of going up initially, I'm going to go down initially, and that's going to help me with that. I also know that I'm going to have a horizontal translation or horizontal stretch in this case of -1/2, and so that's important to think about as well. So my K value, or if I'm thinking about my K value, it's -1/2, and that affects my period. So to figure out the period, you take your 360, you divide it by the K value. In this case, I'm going to use the positive value or the absolute value of my K value, so which is 1/2. So you are taking 360 and dividing it by 1/2 or 0.5, and that actually gives you a period of 720. So remember, when we're thinking about this, and we looked at transformations earlier in the semester, every time we saw a fraction or a decimal number, we knew it was the opposite. So instead of shrinking it or compressing it, it's going to stretch it. And this is where it comes from as well, right? So we're dividing by that 1/2, which is really the same as multiplying by 2 when you're thinking about those fraction rules. So we know that we have a period of 720. And then we're going to take a look at our, we have no phase shift, so our phase shift is going to be 0. And we have a vertical translation of -3. So the vertical translation tells us where our new sort of central axis is going to be. So I'm going to draw that down here at -3. And I'm just going to use the highlighter tool for this. So down at -3, this is where it's sort of going to hinge. All right, so there we go. And now I'm going to come back up, and I'm going to use this to figure out what my amplitude is going to be. So because it's at -3 and I have an amplitude of 1/2, that means that the highest point that my amplitude is going to reach is going to be -2.5, and the lowest point that my curve is going to reach is -3.5. So I'm going to use that when I'm figuring out my domain and range. So the domain is anything. So the value of x can be any possible value for theta. So it's a set of theta such that theta is an element of the real numbers. And the range is the set of y such that y is now going to be between, we talked about this, between -3.5 and -2.5. And you can keep them as mixed fractions like we have here. You could convert them to decimals, or you could write them as improper fractions. As long as you have the right value, it doesn't matter to me how you express that. And that's going to help us out with that. So now I'm going to come back down to the lower part of my grid. So normally I would start here, so at 0, that's also where I'm going to start here as well. So my amplitude and my period doesn't affect where I'm going to start from because I have no phase shift. So this is my starting point right here. I know that I have a period of 720, which is past what we have on the grid, but I can dictate or find the sort of halfway point. So I know that the halfway point is going to be at 360 because that's half of 720, and it's going to be at the other end as well. So I know that I'm not going to be able to draw a complete sine curve in one direction. I can use that to help me sketch as much as I can. I know that halfway between these 2 points is going to be the lowest point of my grid. So that I have a lowest point of my amplitude is 1/2, so at -3.5. And I'm going down this time, remember, because of the negative K value. So we have the reflection. So instead of going up, I'm going to go down. And then on the other side, halfway between my 2 points there, I'm going to have the highest point, so it's going to be right there. So now I can quickly sketch my curve as much as I can in between these values. And sometimes it's harder when we have a shallower sort of curve rather than a longer curve to get it just right, but do your best. I'm going to look again for your dots so we can see which way you're going from there. So I know that's not a very perfect curve, but it's enough to show what we've done there. So now we're going to flip the page and we're going to go over just a couple more cosine ones, and then you're going to have some time to work on an assignment. So looking at our cosine curve, we know that we start this time at 1. So we start at 1. It normally has a period of 360, so I'm going to get back to 1 there. Halfway point is now going to be my lowest point at -1, and then halfway between there is where it's going to hit the x-axis. Or in this case, I guess the theta axis, as you might want to call it. And I know it's going to repeat in the opposite direction. So I can go ahead and sketch in those points. That's not quite high enough for that last one, is it? All right, there we go. So once we've sketched that, we can go ahead and connect those. So this is our basic cosine curve. Not perfect, but you can see how it's going to look there. So there's our cosine curve right there. And now we're going to talk about the domain, the range, the amplitude, and all the other fun stuff for the cosine curve. So the original domain is the same as the sine curve, and it's going to be the same regardless of what type of curve you have or what you're doing to the curve. The domain is always going to be the set of theta, such that theta is an element of the real numbers. Your range is again going to be the highest and lowest points. So it's a set of y such that -1 is less than or equal to y, which is less than or equal to +1, where y is an element of the real numbers. We have an amplitude of 1. We have a period of 360. And we have no phase shift. And we have no vertical translation. So this is our basic cosine curve. So this is what we're basing all of our other curves on this side. So let's take a look at the equation for example B. We have a negative here. So this tells us that we're going to have a reflection. So instead of starting at our highest point, we're actually going to start at our lowest point when we're going to sketch our graph. We have a vertical shift or a vertical translation of +2. We have a k value here that it affects our period. So our period is going to be 360 divided by 2, which is 180 degrees. And we have an a value of 5/2, which tells us what our amplitude is going to be. And you can keep it as an improper fraction, 5/2, or if you wanted to put it into context of 2.5, you can do that. So 2.5 would be fine. So now we have all of the information that we need in terms of drawing this curve. So I'm going to go ahead and draw my sort of new central axis based on my vertical translation. So I know that I have to move this up to 2. And then from there, I'm going to use that information to sketch my graph. So I have no phase shift, so that's important to note. So no phase shift. So I'm not going to move it left or right at all. So normally I would start at my highest point. My amplitude says it's going to be 2.5. So I'm going to go up 2.5. But instead of going up, I'm actually going to go down because I'm starting, because of the reflection, I'm starting at my lowest point instead of my highest point. So I'm going down 1, 2, and a half. So I'm starting right there at -1/2. And this is going to dictate where my lowest point in my range is going to be. And I know that my period is 180, so I'm going to get back to this lowest point at 180. So it's going to be right there. And then from the, I can sketch another curve, full curve on the other side. And I can go ahead and plot those points in the negative direction as well. So this is my highest point. So halfway in between there at 90 degrees is going to be my, that's my lowest point, sorry. Between the halfway point at 90 degrees is going to be my highest point. So here's where I'm starting from, and I'm going up 1, 2, and a half, so at 4.5. And then from there, I'm going to have another one, another highest point at 270. And I'm going to have another highest point at -90. And I'm going to have another negative point halfway at -270. And then from there, I can think of, okay, where am I going to cross this central axis? And it's going to be halfway between those. So right at about 1.5, or sorry, that's 45 degrees. And then again, the same thing between these 2 points halfway, between those 2 points halfway, and between these 2 points halfway. And I'm going to go ahead and put them in for every sort of set. And whatever way is easier for you to sort of sketch this graph is fine, as long as you are sketching it correctly. So now that I plotted all of those, I'm going to very carefully connect those using a curved line. That was a little wonky, but you get the idea. So there's my curve for part B. Now let's talk about the domain and the range. So the domain for this graph, it has, that's really big, I apologize for that. Right, let's get rid of this. There we go, that's better. So I have a domain of theta, such that theta is going to be the element of the real numbers. And my range is between my highest and lowest point. So y, such that the lowest point is going to be -1/2, or -0.5, is less than or equal to y, which is less than or equal to my highest point, which is 4.5. And y is an element of the real numbers. So that's curve 2, okay? All right, now let's take a look at curve 3. Now curve 3, you have to be careful because we only have one bracket inside of the theta section, and we have a k value and we have a phase shift. So we actually have to factor this out so we can really get a true sense of what our phase shift is going to be. So I'm going to have y is equal to the cosine, square bracket, 3, round bracket, theta, and -90 divided by 3 is -30 degrees. Close your curve bracket, close your square bracket, and then add your 4. So once you've done that, you're going to be able to figure out what is your amplitude. Well, we have an amplitude of 1 because there is no number in front of the cosine. We have a k value, so that's going to affect our period. So normally we would have a period of 360 degrees, but we're going to divide this by 3, which is going to be 120 degrees. And we have a phase shift. It's the opposite, so we're going to move it to the right 30 degrees. And we have a vertical translation of 4 degrees, or 4 units. So this is going to move our central axis to the 4. So right up there. All right, so we still have an amplitude of 1. So normally we would start here at the 5, but we have that phase shift. So the phase shift, we actually have to go over 30 degrees. So we're moving over 1 square to the right. We have a period of 120. Remember, each of these squares were 30 degrees. So we're moving actually over 4. So 1, 2, 3, 4. So an entire cosine curve is going to fit in this section. And now we're going to do the same thing over to the other side, or as keep going. So we know that we're going to have another curve here. And we're not going to quite get another full curve in on the other side. But we can go backwards. So I've gone over 4 units. I'm going to go over 4 units. And I'm going to go over another 4 units. And that's as far as I can get to. And then I know that halfway between there is going to be my lowest point. So I still have an amplitude of 1, so I'm going down to 3. So my lowest point is 3, my highest point is 5. That's going to help me when I figure out my range. And now from there, I'm going to then just continue on looking at my lowest points. So halfway between there is another lowest point. So that looks like every 2. So from here, I'm going to go over 2. There's going to be another low point. Or every 4. So I'm going over every 4, and that's going to be a low point. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Not quite. And I know that between every one of those points, I'm going to have it's going to meet at that juncture there. So I actually have a dot every line, every vertical line. All right, so let's go ahead and sketch those. There we go. All right, and lastly, let's just figure out where our starting points were for each of those, because I forgot to circle those for you. So remember, this is where we started for this one. This is where we started for the second one, and this is where we always start for the regular cosine law. So make sure you circle your starting points so I know where your curve is going to start. So when I go ahead and mark that. And did we do that for the other side? We did it for the first 2, and yes, okay, we're good. All right. So lastly, let's just figure out our domain and range for the last one. So the domain is going to be theta, such that theta is an element of the real numbers. And our range is our highest and lowest point. So y, such that our lowest point was 3. 3 is less than or equal to y, which is less than or equal to 5, which is our highest point, and y is an element of the real numbers. I hope that helps. Feel free to send me an email if you have any questions, or take a look at some of the other resources. TVO Mathify is also a great resource for some free online tutoring. There's the after-school program as well if you need some additional support. And good luck on your assignment.